Assalamu alaikum. Today we the course of AI engineering. So let's continue. So I was on debugging and profiling. I did not have the time to learn about this tensor library. What was it called? I tried to learn it, but it was not very intuitive. I only tried sometimes, but then I gave up on it. It was tensor board. I don't know how to use this, but let's continue. If I find some trouble in the future, I will come back to it when needed. So tensor board, let me search what is tensor board used for. And tensor board is used for debug and training of to track, monitor, debug training process of deep learning models. Okay, let's continue then. On to the next part. Yes. So next part is phase 1. That is about linear algebra. Lovely. So implement vector matrix operation, addition, dot products, matrix multiply from scratch in Python. Explain geometrically what the dot product, projection, and Gram-Schmidt process do. Determine linear independence rank basis of a set of vectors using raw reduction. Connect linear algebra concepts to AI applications, embedding attention score and LoRa. Open any ML page. Within the first page, you will see vectors, matrices, dot products, transformations, and linear intuitions. These are just symbols. With it, you can see what a neural network is actually doing, moving points around in space. You don't need to be a mathematician. You need to see what these operations mean geometrically, then they code themselves. It measures the similarity, I'm pretty sure. The problem with this question is all of the answers are just B for some reason. And in AI, what does embedding refer? A technique? No, it's not a technique. It's a vector that represents the position of some word that captures the meaning of word. Yes, this one. Ironic that I said all of the answers B, and in this specific one, the answer was D. Now, the vector has magnitude. Let's see. A vector is just a list of numbers, but those numbers mean something. They are coordinates in space. The vector points from origin z0 to 32 on the plane. Then the magnitude of this will be 3, the square of 3 plus so 3 plus 4, square root of that. 9 plus 4, that is, it's 13. And square root of 13. In AI, a vector represents everything. A vector of 768 number, its meaning in embedding space. An image, a vector of millions of pixel values, a vector of preferences. A user, a vector of preferences. An image, a vector of millions of pixel values, and a vector of 768 numbers. Matrices are transformation. Matrix transform one vector into another. It can rotate, scale, stretch the magnitude. Let me just 1 moment. I have something important to do. Okay, done. Now let's continue. In AI, matrices are the model, a neural network wave matrices that transform input into output. Attention score, matrices that decide what to focus on. Embeddings matrices that map word vectors. Attention matrices that decide what to focus on. Neural network weights matrices that transform input into output. So I have to embeddings. I know it's just a vector that represents a word in a space. And attention score matrices that decide what to focus on. Neural network weights matrices that transform input into output. So a weight is essentially something that transforms the input into an output. Let me look it up even more. What are weights in neural networks? Okay. Numerical values that control the strength of connection between artificial units, determine how much an influence an input has on the output. They act like volume knobs to amplify or mute data signals. So my question, if the weight is large, will the output will be large? If the weight is large, will the output be large as well? So I want to see the relation. Is it direct or indirect? Yes, a larger weight usually means a larger output, but only if the input value is positive and non-zero. So in this case, if the input is a non-zero and it is large, then in this case, the output will be large as well. In negative value, multiplying by log makes the output a larger negative number. So a weight basically makes the output more stronger. So does a weight make the output even stronger? Um, yes, using higher makes your maximum strength output significantly higher by training the neuron to recruit more muscle fibers as well. Oh no, not in in neural networks. Larger influence the input on a signal, but it does not automatically make the overall output larger. So it affects the amplification. Multiplying input by larger positive number increases the raw sum calculated by the neuron before activation. A negative way does the opposite. It reduces or flips the signal, making output in the negative direction. Let's continue. Um, the dot product measures the similarity. I know about this. In two vectors, I'm multiply the x dimension with the x dimension, y with the y, z with the z. And if there is a tensor, meaning a multiple dimension vector, so then in that case, a1 multiplies with b1, a2 multiplies with b2, a3 multiplies with b3. Recommendation system and RAG work and find vectors with the dot products. Vectors are linearly independent if no vector in the set can be written as a combination of the other. V1, V2, and V3 are independent. They span a 3D space. If one in combination of the other, one is a combination of the other, they only span a plane. Vectors are linearly independent. If no vector is the set in the set can be written as a combination of the other of the other. If v1, v2, v3 are independent, they span a 3D space. If they are independent, they span a 3D. If one is dependent on the other, then they span. Wait a minute, there's so many bugs today, and I mean quite literal bugs. So this span a 3 if one is combination of the other, meaning one is in the same space as the other, then it's just a plane. Why it matters? Why if your feature matters should all have linearly independent columns. If two features are perfectly correlated, linearly dependent, the model cannot distinguish their effects. They cause multicollinearity in regression. The weight matrix becomes unstable and small inputs can change. The input changes produce wild output swings. So V3 is equal to 2 times V1 plus V2. So V1 and V2 are independent, but V3 is dependent on the other. Neither is scalar multiple or combination of the, but V3 is a dependent set. These three vectors all lie in the xy plane. No matter how you combine them, you cannot reach 0, 0, 1. You have three vectors, but only two dimensions of freedom. Okay, so if the third vector can come out as a combination of the other two vectors, then it is dependent on the other vectors, and it cannot come out as something else. It cannot come out of its two dimensions because the vectors is dependent on those two dimensions. Okay. In a data set of feature 3, feature 2, adding feature 3 gives the model zero information. Worse, it makes the normal equation singular. There's no unique solution for the weights. So essentially speaking, I should make sure that the vectors are not dependent on each other. One thing I want to understand the definition of is regression. What is regression? Returning to an earlier, usually worse or less developed state. Regression in machine learning. A type of supervisor used to predict continuous numerical output by analyzing the relationship between independent features and a dependent target variable. Unlike classification models that group data into discrete categories, spam or not spam regression algorithm answer how much or how many, such as predicting a house prices, temperature, or stock market trends. All right, let's continue. A basis is a minimal set of independent vectors that span the entire space. I know this is just identity vectors. The number of basis vector is the dimension of the space. The standard basis vector for 3D spaces, this presents x, y, and z. So this is essentially a 3D vector. But any three independent vectors in a 3D form a valid basis. The choice of basis is a choice of coordinate system. Rank of a matrix, number of linearly independent columns equal the number of linearly independent rows. If rank is less than the minimum, the matrix is rank deficient. This means the system has infinitely many solutions. Okay, so I see. So the rank is the number of independent column, and so meaning that the columns and the rows are all independent of each other, and if the rank of the matrix equals the number of rows and column, meaning if there are 3 rows and 3 column and the rank equals that, then that means that the matrix is um, full dimension essentially. So none of the vectors are dependent on each other, and it has full freedom in the moment in the space that is defined by those vectors. Now, if the rank is less than the minimum rows or columns, then the matrix is rank deficient. This means the system has infinite many solutions or none. Information is lost in the transformation. The matrix cannot be inverted. So if the one matrix is dependent on the other, then that means that if I transform it, it is not untransformable into the previous form. Okay. Full rank, the maximum possible and unique least square solutions model is well conditioned. Rank deficient rank is less than minimum and below maximum. Features are redundant, infinitely many weight solution regularization needed. But rank deficient, meaning the rank is less than the minimum number of I need to memorize it. A rank is equal to the amount, the minimum of the rows or the columns. Unique the least square solution exists. Model is well conditioned. This game regularization is needed. Rank 1, every column is scaled copy of one vector. All data lies on a line. Near rank deficient, smaller singular value. Numerically low, matrix ill conditioned, tiny information has large input output changes. Use CVD truncation or rigid regression. Okay. Projection. Projecting a vector onto another. Okay. Gives the component of A in the direction of B. I know that draw.io is if that is a online drawing website. Sketchpad, yeah. Cool. Actually, auto draw might be cool. I think I heard this. Start drawing. So basically, A dot dot B is equal to, my drawing is terrible with the mouse pad. A B cos theta. So I know that this right here is the projection B project proj. So essentially speaking, if I rearrange this, I can find the um, projection of B on A. So if I divide this by this, A is this represents the magnitude. I should put this here, most probably. And yes, so this is going to be the projection of B, meaning how big is the essentially the shadow of B. Okay, how big is the shadow of B? Now similarly, I can do the opposite, which is that I can put A there and B comes down. In that case, it is divided by B magnitude, and A dot B and B dot B. Where does that come from? Is this correct? A dot B and B dot B. B dot B, where does that come from? B dot B, B dot B. Am I mistaken? I think that's incorrect. Formula for dot product. Is this correct? Is this correct? I doubt that this is correct for some reason. I need to ask an AI because it will take time. Is this formula correct? Is this formula correct? This is correct. Why? Breakdown of why this first. I would need to essentially derive this on my own. Oh, I understand. I understand. So if I have the magnitude b hat is equal to b by b, I can rearrange this just to get the b. So essentially, I get this. Projection A is A dot B, B dot B. Okay. So magnitude, I can say that it is B dot B is the magnitude. Um, is that correct? B dot B, where is that? A dot B divided by B magnitude. I know that I can rearrange this to get B hat. So combining them, A dot B, this, and I have the unit vector. To give the scalar a vector direction above along B, you multiply the unit vector in the direction of B. This is confusing. I need to derive this with my own two hands. I want to open up my bag. I'm going to get that pointer. Where is it? Um, what I don't understand is where does that even come from? So this formula is correct. I need to understand it. I know that projection of A is equal to A dot B divided by B ka magnitude, B magnitude. Now B hat is equal to B divided by B magnitude. I know that. Now Where does this come from essentially? Why is it putting it there? Why is it multiplying it like that? Um, where did you get the formula? How did you derive this A dot B? No, actually, I want to ask, how did you put the unit vector equal there? Basically, how did it put this here? There was no B hat there. There was no B hat there. How did you put it there? Because if it is multiplying its own on its own, it needs to divide its own as well. So what the vector? Each vector is made of magnitude, length, and the direction. Is the length of the shadow of A onto B. So A dot B, B, okay. And there is some direction. Does the projection in the dot product have some direction? Is it a vector? But is scalar projection or vector projection? Vector projection is a different thing. What is vector projection? I have heard about scalar projection. What is vector projection? One vector pointing the direction of another vector. So projecting a vector onto another. Light shining down at you, so it's just the number of the length of the shadow. Okay, I understand this enough. Yes. If it's another, so it's going to be in the direction of B. So the projection A on B, so it's there forms a shadow. It forms a shadow over here, so in that case it will be in the direction of B. So substitute this with B and divide by B magnitude, B magnitude. At the bottom it's become A dot B, B dot B, and at the bottom it becomes B magnitude. Take a square, B magnitude essentially. Vector projection on Wikipedia. I should keep Wikipedia off. Also, a vector non-zero B is the orthogonal mean perpendicular projection of A onto a straight line parallel to B. This is the web projection. This is going to be along with B. A dot B, and in the direction of B, so I multiply. Oh, this makes formula makes more sense. This equation makes a lot more sense, I think. So in this case, okay, it's BBB squared. So B magnitude it's a square, so this becomes B squared essentially, B dot B. Why don't it doesn't it cancel it out? It does not cancel it out. Oh, I understand. Since we are not trying to find the magnitude of the bigger vector, we are trying to find the actual projection, the shadow. Um, and one more thing, does the okay, pick the direction. B, if multiplied by B, where x can scale vector by the length B is equal to Z, this value must multiply the exactly one pointing in the direction. So A dot B by B gives me the essentially the magnitude of the projection. But I do not desire the magnitude of the project. I also want the direction. So I multiply it by B hat. So this gives me the essentially the length of the vector in the direction of the projection. I think I understand now. One more thing, does the simple A dot B divided by B magnitude give me the length of the uh, projection, while the A that formula above give me the vector projection scaled by the magnitude, meaning the length. Oh, my internet has gone bad for some reason. Oh no, oh no. Okay, I am starting to understand that. So if I do that, it basically gives me the only the direction or only the length. Why is there is no sound? Is the sound visible? I need to check if the sound is visible. Hello? Hello? Okay. Um, I need to produce some sort of sound here. I think it's fine. Okay, I understand. Now let's move on. Projection is everywhere in ML. Linear regression minimizes. Why is this light not turning off? I don't understand. Well, whatever. This article is the foundation of least square fitting. I don't know that, but okay. What is least square fitting? Least square fitting. Least square. Is the method to determine the best fit model by minimizing the sum of the squared residual, the difference between observed values and the values predicted by the model. So it is regression, least square approximation, redirection at the completely least square function of obviously. I shouldn't be confused with that, yeah. I don't understand it probably. It's basically sum of the squares, fine, and meaning every single dot, the sum of the dots, square of the dots. This is too long to read. It's gonna fry my brain there. Okay. Projections every linear regression minimize the distance from the observation to the column space. The solution is a projection. PCA projects data on the direction of maximum variance. I don't understand, but PCA, what is PCA? They just throw around terms and expect me to understand in machine learning. PCA in machine learning, unsupervised. Oh, there is PCA, principal component analysis. What? What do you mean? PCA, principal component analysis. Okay. Medium network is slow for some reason, but attention in transformer computes projection of Curie's on the. I know about attention. It's basically memory. Is attention essentially memory of the AI? If my internet works well, I can find the answer quick. I guess I'll have to do it. And example, okay, it is working. Is not essential. Okay, I was wrong. Tension acts as a dynamic focus and routing mechanism. This allows the AI to evaluate connect different parts. The spotlight attention functions like a spotlight rather than a filling cabinet. When we processing a piece of text or data, it assigns a mathematical weight score to determine which other elements are relevant to the current piece. No built-in persistence. I don't know about all this. Attention functions like a piece of text data. It assigns a mathematical weight score to determine which other elements are relevant to the current piece. So it essentially highlights the important bits. Okay, I'll read about it more later, I guess. And example, I know about 3 multiplied. Okay, so I should calculate this on my own. So it is the A dot B dot B by the B dot B and B vector. All right, it's B squared. So A dot B is 3. It's 3, so 3 and 4 0 0. B dot B is just 1 square, 1 square, and that is that. So it's 3 0, I think. 3 0. Yeah. The projection drops the y component. This is dimensional reduction. The simplest one throws away the direction so you don't. Gram-Schmidt's process. How do you pronounce Schmidt's? Schmidt. Gram-Schmidt's process. A linear that takes a set of linearly independent vector, meaning the rank is equal to the minimum number of rows or columns. Essentially, all of the vectors are not some combination of the other vectors in some way. Okay, pronunciation. How do you pronounce this? Schmitt's process. Okay, whatever. Why I'm looking at this Schmitt's pronunciation. Um, um, Schmitt's. Okay, let's see. Why am I looking this up? Schmidt, Schmidt, Schmidt. Okay, but I like Schmidt, Schmidt. Converting any set of independent vectors into an orthogonal basis. Orthonormal basis. What is orthogonal is perpendicular. What is orthonormal? Is a linear with the theories with application that is a linear geometry for such that the direction is become a capital largest variation easily identified. I don't understand this fully, but whatever. So orthonormal. Two vectors in an inner product if they are orthogonal unit vectors. Various meanings depending on the context. A unit vector means that a vector has length 1, which is normalized. Orthogonal means two vectors are perpendicular to each other. The orthonormal means the vectors are perpendicular to each other and they have the length 1. So does orthonormal mean that the vectors are perpendicular and have the length of 1? Yes, good. So orthonormal, it's orthogonal and normalized. Means every vector has length 1, every pair is perpendicular. It was quite literally on the next line. The algorithm takes the first vector, normalizes it, Take the second vector, subtract its projection onto the first. I haven't even coded today. Coded in this particular, coded anything about AI today really. I coded other things. Take the first vector, normalize it, take the second vector, subtract its projection onto the first and normalize this. Take the third vector and subtract its projection onto all previous vectors. Normalize. I don't understand, but let's try. Okay. So I know about normalization. Basically, vector it is calculating the u hat, u1 hat essentially. So the vector and u1 hat basically, so vector divided by the magnitude. Now it's subtracting the, why is it doing that? So it is v dot u1. So let me understand. So I calculate that vector. Imagine I have three vectors. Okay, I calculate the unit vector of 1, then I calculate the v2 minus v dot u1. So v2, okay. What I'm essentially doing here is I am finding the projection and scaling it by u1, scaling it by u1 times, and subtracting that from v2. Why? I don't get it. I want some visualization of this. Gram-Schmidt's process. Gram-Schmidt's process. So this vector projection, so it essentially makes all the vectors perpendicular to each other and normalizes them. So this is how it works. Is there animation? So it takes the two vectors, v2 u1, u2, u2. I don't understand properly. Okay, v2. Okay, so this is the projection, the axis projection, and this is the it is in the opposite direction. Okay, let me see it again. This is hard to imagine. This is hard to imagine. So yeah, what is Asian direction? What are these terms? Come on. What is Asian direction? Now, come on. Wikipedia. This is a lot more fun than section. So what is the Asian? Like what is what is the pronunciation? What is spelling it first? Egen. E Egen. Like that. What is it? Eigenvector character is a non-zero vector that its direction unchanged or reversed by a linear transformation. So a vector that is non-zero and it is reversed by a given linear transformation. For processing eigenvector v of a linear transformation t is scaled by a constant factor. Okay, so that's the corresponding eigenvalue, heuristic value, or heuristic root is a multiple factor of lambda or something. So an eigenvector is essentially just a vector in the same direction, but same or opposite direction, but it is scaled by some value. It is 3 minus 3, for example. That's what I understand from this. All right, this is how QR decomposition works in Perl. Q is orthonormal basis, and R captures the projection coefficients. Projection coefficient. QR decomposition is used in solving linear system, more stable than the Gaussian elimination, and computing eigenvalues. QR algorithm, and least square regression, the standard numerical method. I still do not understand this until I code this myself. Matrices from scratch Python. Why this matters for AI? Julia version. I think I should try Julia first because that seems more fun. And that's the cosine. How do I write this square root? Julia supports Unicode operators. I what I don't understand is Gram-Schmidt's process, but I need to code it myself to understand. I need the visualizations for this Gram-Schmidt's process visualization, step by step 3D visualization. It is 70 years ago. No, something else. Maybe this Gram-Schmidt's process. Visualizing the lab version. Engaging turbo thrusters. Okay, step. So this is the vector. So so first I calculate v1. V1 is essentially this vector, the unit vector of this vector. It can be any other vector, I think. I could also calculate the unit vector this, or this. So I choose u1. I calculate the unit vector for this. Good, good. So 2220. So that's v1. Now I calculate the u2. I calculate u2 minus the projection of, so u2 I got it, u2 minus the projection of v1 onto u2. So v1 onto u2, I minus this projection from here. So this becomes it is in the opposite direction. I don't understand fully. So v1, this is v1, okay, and v1 u2, this is 5. v1, okay, u2, v1 onto u2, v1 onto u2. Let's go back to the previous step. Then I calculate the v2 by v1 on v1 dot u2, the projection of v1 onto u2. Then I do u2 minus projection of v1. I want to know what this is, the projection of v1 onto u2, like in this equation. In this case, it's v2 dot v1. Here it's the opposite. Oh no, it's projection of v1 multiplied by u2. Is that correct? Projection of, no. That is not correct. This is hard to understand. This is difficult to understand. How does this form a variable? So it forms these two vectors. Now it forms u3 minus v1 u3 u3 minus subtract from it projection of v1 onto v3 v1 onto v1 onto u3 v1 onto u3 and v2 onto u3. I don't get it fully. I need some more visualization. This is what you call visualization. What the hell is this? I understand it's doing that, but I want to see the actual security check required. Okay. ResearchGate Python programs in 2 dimensions. This is the Python concept visualization. What library does it use pyplot for? I don't understand this fully. I don't understand this fully. I will understand, I think, when I code this on. But I do understand I need to calculate the unit vector, then I need to subtract the I need to calculate the second orthogonal vector. So all I do is to take the second vector, subtract the dot product of uh, this. I subtract the dot product of the projection from there. So V2, and I imagine that this will be, then I calculate the unit vector for that. Okay, and then I calculate the W3, W3. In every case, I subtract from this value. So I subtract this entire thing. V3 dot product with that, V with that. So whatever I'm taking the dot product with, I multiply it by that as well. I'm multiplying by taking dot product with 2, I multiply with 2 as well. And that's that. This is not helping in the visualization, but whatever really. I understand the concept of what it's trying to do. I just need an actual visualization. I need some more visualization for this. I need some more. Okay, now let's code a bit. Okay, let's do some coding now, finally. Yes. Phases, and in the second it is the step for ML fundamentals. ML funda ML fundamentals. Yes. In this I will create vector.py. I will create a class and it's going to be of vector. I should do this in Java because oh no, my the AI. Shush, shush, shush. No, don't do it. So I need to create a constructor. I have heard of a constructor. Do I just make the name? Okay, definite. And I want to do this in Java. This will be better because I know the syntax. So I initialize this vector with an x and y. Now what is this self.components? What is components? What is self.components in Python? Oh, so this is like self.x is equal to something. This self.component is equal to this or something. How did they do it? So they did it by self.components is equal to list of components. What am I doing? So self.dim is equal to the length of self.components. Is that correct? So it creates a list of the components, meaning if I has three, it makes three, and this should not be dim, it should be dimensions. They should name it too. So dimensions. Diff add. So does Python have operator over loading? I think it does. So I can do this. So I can do vector. Oh, so this it does have. Okay. Self dot vector. Okay. So all I have to do is self dot. So for each one, I will subtract from the other, right? I want to understand what zip is. Dev docs.io. I want to understand zip Python. Zip aggregates element from each of the iteratives. Okay. So A, B, C, D, this creates A, X, and B, Y. Okay. It takes a list of iterables and iterates all over them. I should do this in the terminal to understand what that means. Next, that aggregates elements from each returns an iterator of tuples where the ith element is derived from each of the arguments. Start and shorter groups iterable is exhaustive with a single iterable argument. It returns an iterator of one tuple with no zip. So let me understand this. A Python 3. So let's say our list 1 is equal to 1, 2, 3, 4, 5. And list 2 is equal to 10, 20, 30, 40, and 50. Then I do zip list 1 and list 2. Okay, I should do print zip list 1 and list 2. Why is it not doing that? So is it an intervar t in zip list 1 list 2? print t. Oh, so it creates an iterable and it creates a tuple and it merges them. What if one of the lists is smaller? One, two, three, actually list two is smaller. Then what does it do? Complete. Let's do this and I will do the above again. 1 and 2 and it stops. Oh, cool. Okay, cool. Now let's continue with these even more. So self-taught components. How did the I don't have that much Python experience. So it returns a new vector. It return vector where the dimensions are the same. A plus B for a self-dot components and other dot components. So it takes the other. Okay, so return the vector where it's a list, it's essentially a list. But I don't understand is if this one to take for A, B in the zip self-dot components and other dot components. I think this is correct. A and B, it adds A and B, but it returns a list. But I don't understand if this list of list, what if I create a list of lists in Python? What does that do? So let's say I already have that, it's a list. So list of list one, it does nothing. Does list of list one do nothing in Python? Creates a shallow copy, a brand new list element. This was not created when both variables point to the exact same person by we modify list to list one will also. Modifying the structure like adding removable lead list one and so it creates a shallow copy. They have the same values. List one is they have the same list one is equal to the list two. They are not the same objects in them. They have the same values. They are not the same objects. What is a shallow copy in Python? I don't understand this correctly. Creates a new outer content object but inserts references to the item found in the original website item from the distributed top level contains complete independent mutable the list string remains shared between adding to the outer container will not affect the original structure. Modifying the shared nested mutable object will reflect in for the original and the copy. Here's the original, here's the shallow copy. Shallow copy print the element. I still don't understand. Wikipedia help me. English and shallow copy. Object copy. One method copy in that a new object B is created. The field values of A are copied to B. This is known as field to field copy. Okay. Field to field or field copy. If the field value is a reference or to an object, it copies the reference, hence referring to the same object. That's it. If the field value is a primitive type, it copies the value of the primitive type. Without primitive type, each is an object. So essentially, it's what it's saying is it creates a new memory and it creates a new object and copies all the values from the previous object into the new object. But if the previous object has a reference variable inside it, like another object, it does not copy the internal object. Instead, it only copies the reference to that object. Okay, okay, so I understand. Let's complete this and then I have to. Actually, I might self other return b vector a minus b for b in zip self dot components other dot components and that dot self and other. Uh, it takes the other and returns a value of self dot. So what does it do? It multiplies A with A, B with B, and C with C. Hmm. I could do this, for example, result is equal to 0. And I could simply do for A and B in zip self dot components and other dot components. I simply do A multiply B and add that to the result. Result is equal to A and I add them, both of them, continuously and in the end until it's time the result. I could do that. Is that correct? A multiplied B or sum. Oh, that's another output. But is my method correct? I want to just confirm it for a second to gain some confirmation. Is this correct or is there a mistake in this? Yes, it's completely correct. Yes, dear. Yes, it's fine. So that's enough for today, and I will continue tomorrow, inshallah, with this. And I need to, for tomorrow, what I need to do, actually, I can commit this. Git add, git commit to do uh, complete vector implementation and learn about Gram-Schmidt process more and visualize visualize it. Git push, and that's good for today. And thank you for watching. Allah Hafiz. Bye bye. I will see you later inshallah.